Hi Year 11 Mathematics Advanced students. Today we're starting a new topic of functions, and the first exercise in this topic is just called functions, and we get to know the different types of functions. What I want you to actually do before you get into this lot of theory notes is to stop the video and go to the first page on the terminology of functions. I want you to read through it and make sure that you're familiar with all of the terminology and the different terms, because some of them we have never seen before and we're not going to know what they are. So if you get a head start and look at what they mean and what they are, then that's going to help you in the long run. So pause the video right now and then come back once you have read that page. Okay, hopefully you have read all of the terminology, and let's get into the theory notes. So for functions, what we're doing today is we're getting to know functions, getting to know what a relation is, the types of relations, as well as some tests we can do to tell whether a set of ordered pairs or a graph is a function. So a relation is a set of ordered pairs x, y, where the variables x and y are related according to some pattern or rule and each other. For any value of x, there could be more than one value of y. The x is called the independent variable. So our x is called the independent variable, and the y is called the dependent variable, because the value of y depends on the value of x. So what we know so far about x and y and ordered pairs is what we've learnt from coordinate geometry. And when we do a table of values for coordinate geometry, what we do is we put the x on top over our y. You do not need to write this on your theory notes. And we would be given x values, right? And then depending on what our equation is, or our function in this case, depending on our x values depends what our y value is going to be. So what we're going to look at is that we usually choose a value of x and use it to find the corresponding value of y, like I just mentioned. And a relation can also be described as mapping between two sets of numbers. So we let the x be the set of values for a, which is on the left, and we let y be the set of values for b on the right. Now we're going to look at the types of relations. So our first relation that we have is one-to-one. So a one-to-one relation is a mapping where every element of A corresponds with exactly one element of B, and every element of B corresponds with exactly one element of A. So each element has its own unique match. So what we know is that our X is our A and our Y is our B, set of B values, okay? So we know that our A is our independent, our B is our dependent variable. So every X value has exactly one value of Y is the key point. So if we look at this into a bit more detail, we have that 1 maps to 4. We then have that 2 maps to 1. We have that 3 maps to 2. We have that 4 maps to 5. And we have that 5 maps to 3. So only one value of x is matching to one value of y. Or in our case, one a value is matching to one y value. So an example of this is every student has their own unique ID. The next type of relation is one-to-many. A one-to-many relation is a mapping where an element of A corresponds with 2 or more elements of B. For example, 5 in set A matches with 5 and 8 in set B. So let's have a look at this in a bit further detail. So for one-to-many, we have that our A is our X, and we have that our B is our Y. So every X value can have more than one corresponding Y value. So for our X value of 1, for example, our X value of 1 has 2 Y values. It has 1 and 6. Then, our X value of 2 has 2 Y values as well, 2 and 3. Our X value of 3 has only one Y value of 4. Our x value of 4 only has one y value of 7. And like I said before, our x value of 5 has two y values of 5 and 8. So an example of this is in a retail database, one customer can have many order IDs and orders. So if you ever work in, in retail, you will see this. The next relation we're moving on to is many to one. So that it says that more than one value of x maps to the same value of y. So let's break this up. So we have our x values as A, our y values are B. So more than one value of x maps to the same value of y. If we look at this into some more detail, so our first value of 1 maps to one y value of 1. Our x value of 2 maps to our y value of 2. Our x value of 3 maps to our y value of 3. So this is where more than one value of x maps to the same value of y. So 2 and 3 map to the same value of 2. We then have 4 maps to 5. We have 5 maps to 3. We have 6 maps to 5. We have 7 maps to 5 as well. And we have 8 maps to 3. So as you can see here, for values 2 and 3, they both map to 2. So one x value maps to the same y value of y. And then for 4, 6, and 7, those x values all map to the y value. So this is an example where, like many cities within the state of New South Wales, so the cities would be our x, the state of New South Wales is our y in this case. So a many to one relation is a mapping where two or more elements of A correspond with the same one element of B. Finally, moving on, we have our many to many. So when we look at our many to many, we have that a many to many relation is a mapping where two or more elements of A correspond with two or more elements of B. This is a combination of the one to many and many to one relations. So more x values map to many y values. So let's have a little look into this. So 1 maps to 3 and 4. We have that 2 maps to 1. We have that 3 maps to 1 and to 2. We have that 4 maps to 3 and to 5. And we have that 5 maps to 3. So this is basically a bit of a crazy situation going on, because we have stuff coming out of our x values in A and stuff coming out of our y values in B, but our A values, more than one can come from the same place. So more than one x value can map to more than one y value, and more than one y value could have another x value. Okay, so there are 4 types of relations. Next, we're going to look at functions. So a function is a special type of relation where for every value of x, there is a unique value of y. So for every value of x, there's a unique value of y. A function could be a one-to-many or a many-to-one relation. So let's go back to our notes. So a function can be a one-to-one. So that means that this is a function. So 1-to-1 is a function where we have our 1-to-1 is this purple color. So 1-to-1. Or we have our many-to-one is also a function. Is a function. So this means that we have many-to-ones and one-to-ones as functions, and our one-to-manys are not a function, and our many to many's is not a function. Okay, and that's where our many to one is this colour. So all functions are relations, but not all relations are functions. So that means that these are all relations, but only our one-to-one and our many-to-one are functions. We also have the domain, which is the set of all values of x for which a function is defined, and the range, which is the set of all y values of y as x varies. Now we're just going to take some time out to have a look at some examples so that we know how to answer questions. So we have our first example is that this table matches a group of people with their eye colour. So we have the people, Andrew, Barry, Kate, Darcy, Ellie, Frank and George, and we have the eye colours of brown, blue, grey, brown, green, brown, brown. So what we're going to do is we are going to list the ordered pairs. So when we list ordered pairs, we want to write our x and then our y value. So in this case, it's just like a normal table of values. Our x is on the top and our y is on the bottom. So our x is our person and our y is the colour. So what we're going to do for these is we're going to just write our ordered pairs out. So our first ordered pair is Andrew and his eye colour, which is brown. Then our next ordered pair is Barry and his eye colour, which is blue. Then we have Kate and her eye colour, which is grey. We have Darcy and her eye colour, which is brown. We have Ellie and her eye colour is green. And we have Frank and his eye colour is brown. And finally we have George and his eye colour is brown. So that is listing the ordered pairs. Our next question in this example asks, does this table represent a function? Why or why not? So this table does represent a function, since for every person there is a unique eye colour. So if we were to draw this out with our A set here, we would have, so this is our A's, so we would have Andrew, Barry, Kate, Darcy, Ellie, Frank and George, and they would be in our A set. And then we'd have our B set over here, where we'd have brown, blue, grey, and green as our eye colours. Okay, so if we map this like so, our A Andrew goes to brown, our B Barry goes to blue, our C Kate goes to grey, our D Darcy goes to brown, our E Ellie goes to green, our F Frank goes to brown, and our G George goes to brown also. So this table does represent a function, because since for every person there is a unique eye colour, so each person is going to a different eye colour. Okay, so our answer is yes, it is a function. Because every person is going to a unique eye color. So basically, when you have a set of ordered pairs like this, as long as this X values are all the one, so as long as there's not a double up of these, it means as long as there's not a double up of our X values, that it will be a function, pretty much. So as long as there's not a double up of our X values, it will be a function. Next, we need to answer what is the domain. So our domain, if we just scroll back up, is a set of all X values for which the function is defined. So our domain is our X, and up here we have said that it is our set of people. So it's the set of people. And what is our range? Our range, if we scroll back up, is our set of Y values as X varies. So it will be the set of eye colours. E, final question, what type of relation is it? So to work out what type of relation is it, we need to have a look. Because we have said that it is a function, remember, if we look back, it can only be a 1-to-1 or a many-to-1. So it's not going to be a 1-to-1 because each person doesn't have a different eye colour. So in this case, it's going to be a many-to-1 because more than one value of X maps to the same value of Y. So it is a many-to-1. If you get stuck with questions like this, big tip is to draw this diagram here like I have. So draw your set of ordered pairs into the relation diagrams. It makes a huge difference. Moving on to example 2, we have a relation diagram. So for this relation below, list the ordered pairs. So we're going to list them. So we have A maps to 2, so we write A2. Then we have B maps to 4. C maps to 1. And D maps to 3. So that was nice and simple. So we just follow our arrows and we make sure that when we're doing that, we write our X values down first. Whoopsies. So we write our X values down first and then our Y values down like so. Okay, does this relation represent a function Y or Y not? So we have drawn this, and when we look at it, remember that every X value, if it's a function, it should only have one thing coming out of it. Okay, so every X value should only appear once in our set of ordered pairs. So because this occurs, it is a function. So we write, yes, it is a function. It is a function because every value in A corresponds to exactly one value in B. Now we need to state what our domain is. So our domain is always on the left, okay? And it's our X values, which are always on the left, our independent variables. So our domain is set A, which means our range is set B, our Y values. And then we need to state what type of relation is it. So we can see from this, we could flip back and have a look, but I think this one's pretty clear because every X value goes to to only one Y value. So this means that it must be a 1-to-1 relation. Finally, example 3, we have a relation below. Let's list our ordered pairs. So we have M to 1, we have M to 2, we have N to 1, we have P to 4, we have Q to 3, and we have R to 2. So does this relation represent a function or not? Hopefully when you're writing down the set of ordered pairs, you're going, this is not a function, because it's not a function, because these X values appear more than once in some cases. So in this case, we have M appearing twice. So because M appears twice in our set of ordered pairs as our X value, it means that this is not a function. So our answer is no, it is not a function because there are A values in set A that, that's meant to say 2 values. No. No, because it's not a function because there are values in set A that correspond to 2 values in set B. You won't really be asked to explain why or why not it's a function, but as long as you know that you check for if the x values repeat or not, and if the x values repeat, it's not a function pretty much. So because it is not a function, we need to work out what type of relation it is. So if we flip back, the only type of relations we have that aren't a function is one to many or many to many. So in this case, if we have a look, it is going to be many to many. This is because we have M and R both correspond with the same value, as well as M going to 2 different values. So our case is going to be it's many to many. Also, if you're stuck and you have a picture of the relation or you've drawn a picture of a relation, just look back at your notes for now. You're going to get better at doing this, and it's just all going to be about practice. Moving on, we're going to talk about some tests that we can do when we have some graphs to tell whether our relations are functions or not, and what type of relations they are. So the first thing that we're going to look at is the vertical line test. So the vertical line test tests whether a relation is a function. If you draw a vertical line across the graph and it only cuts the graph once, then there is only one y value for the x value. So it is a function. So it's like when we do it, when we do our table of values, we have more than one x value repeated, then it's not a function. So if any vertical line crosses a graph at only one point, it is a function. So it is a function. This shows that for every value of x, there is only one value of y. So here we've drawn 2 lines just to show that no matter where you draw your vertical line on your graph in our first picture here, it's only ever going to cut once, no matter where you draw it in this case. So it means it is a function. If any vertical line crosses a graph at more than one point, then the graph does not represent a function. So this shows that for some value of x, there is more than one value of y. So here we have 2 points crossing our line, and anywhere we drew our line here, it doesn't matter if we draw it somewhere and it only has one. You have to be able to draw it in every single place and only have one point where it crosses the vertical line. So for our examples, does each graph or set of ordered pairs represent a function? So what we're going to do in this case is we are going to draw a vertical line, simple as. So if I draw my vertical line here, it crosses here. If I was to draw my vertical line anywhere else in this picture, it would cross only once. So when it does that, it means that it represents a function. So our answer is going to just be the graph. Holy moly, what's that? Sorry. Our graph represents a function. Okay. B. Does each graph or set of ordered pairs represent a function? So if we draw a vertical line, anywhere we draw it on here, it's going to cross twice. So because our vertical line crosses twice, this graph does not represent a function. Keyword there is not, so that's why it's in capitals. Now, if we look at C, does this set of ordered pairs represent a function? So if we were to look at our x values, like we just did in our other examples, do any of our x values repeat? So we have -2, -1, 0, 1, and 2. Because they do not repeat, this means that this set of ordered pairs is a function. So it is a function. And D. This one's a little bit tricky. So the open circle at x equals 3, which you should have learnt about in equations and inequations, on the top line means that x equals 3 is not included. It's like when we have greater than or less than, but not equal to. While the closed circle on the bottom line means that x equals 3 is included on the line. So it's when we have less than or equal to, or greater than or equal to. So that means when we draw our vertical line through these dots, it only is going to cut here at x equals 3. It's not up here. No, it does not cut in because it's not equal to 3. Okay, so a vertical line only touches the graph once at x equals 3, so it is a function. Hopefully I made that clear for you. Moving on, we have the horizontal line test now. So when we look at our horizontal line test, we are going to see that the horizontal line test tests what type of relation the function is. So we've tested using the vertical line test, and now we want to know what type of relation the function is. So if the horizontal line cuts the graph more than once, then it is not a one-to-one function, but it is a many-to-one function. So it is not a one-to-one function, but it is a many-to-one function. And this is where if a horizontal line cuts the graph more than once, okay, more than once, then it's not a one-to-one function. It's a many-to-one function. But if it cuts it only once, then it's a one-to-one function. So if any horizontal line crosses a graph at only one point, there is only one x value for every y value the graph represents a one-to-one function. So right here, it only crosses once. So it is a one-to-one function. Okay? If any horizontal line crosses the graph at more than one point, like here, here, and here in this example, this means that there are two or more x values that have the same y value, and the graph does not represent a one-to-one function. So the graph does not represent a one-to-one function, but let's just add in here, it represents a many-to-one function, okay? So it's important that you write that down. So it represents a many-to-one function. Okay, some examples. Does each graph represent a one-to-one function? So if we were to draw our straight line anywhere through, it crosses more than twice. Oh, it crosses more than once, sorry. So it does not represent a one-to-one function. So does each graph represent a one-to-one function? No, the graph represents a many-to-one function. And finally, B, if we draw a horizontal line anywhere, could draw it there, could draw it along the x-axis, could draw it here. It only crosses once, no matter where I draw my line. So because it only crosses once, yes, this is a one-to-one function. If you are following through the Margaret Grove textbook, yes, it is the Maths in Focus textbook, you would now do the exercise that relates to functions. If you're in advanced, so for advanced, it is exercise 301, and if you're following the extension 1 textbook, it's exercise 401. And there's only